Howdy, I'm Gary, Dillon Precision's Human Manual, and I'm going to educate you on how handgun dies work, what they do, and why we do things in certain orders. So, when you're reloading, you're starting with a fired piece of brass. Now, you'll notice it does not just slip into the die and fall out. It's going to have to be a press fit. You'll also notice that the bullet goes a fair amount in there, and the bullet's got to be held tightly into the case to ensure that the bullet doesn't get pushed back in when it's chambered and fired, because that can cause high pressures. So we're going to set up a size die. So start off, goes into station 1 in the tool head. So pull the handle down on the machine with your fingers. Screw the die down until it contacts the top of the shell plate. Do not tighten the lock ring yet. We're going to take our fired piece of brass, slide it into the shell plate, and pull the handle down. Now, with the handle down and the case up in the die, now we tighten our die lock ring. The reason for that is that there's a little bit of slot between the female threads in the tool head and the male threads in the die. By having the case up in the die when we tighten the lock ring, it centers the threads of the die in the tool head. And locking it in place under a load also means that you've got consistent upward pressure on the tool head, just like you will when you're actually reloading. So now we're going to lift the handle up, pull the case out, and you'll notice it's even tighter. The bullet doesn't even start going into the case. But you still cannot take the case and push it up into the die with your fingers. Unless your last name is Schwarzenegger, you need the leverage of a machine to do that for you. Next, we're going to expand and flare the case mouth. Now on handgun cartridges, you want to flare the case mouth out so that you can get the bullet to start in there, so that it doesn't shave anything off the sides of the bullet. So you need to put your die from your powder measure, and I always recommend leaving about 9 threads showing. That's a good starting point. And leave the lock ring loose. Now, in your conversion kit, you have the powder funnel. Now, when you resize a case, the size die is going to size the case to smaller than bullet diameter. That way you have tension to hold the bullet in place. So the expander is going to go in and be forced into the neck of the case to open up the case neck to a uniform inside diameter. And then the case is pushed up onto this 30-degree flaring shoulder to flare the case mouth to somewhere between 10 to 20 thousandths larger than the sized unflared case mouth measures. We do this so that when you set a bullet on the case, it doesn't just tip over, and when the bullet is seated, you don't shave any material off the side of the bullet. So out of our conversion kit, we have our powder funnel. It's the letter E on a Dillon machine for 45 caliber. So we drop that into the die, station 2. So we slide a case into the shell plate at the powder drop position, which is where Dillon equipment flares the case. And for us, we need to put the powder measure on top. And we're just going to finger tighten these 2 screws to keep the powder measure from getting pushed off the top. So now we're going to pull the handle down, and you're going to watch powder bars all the way over. So now we're going to start pushing the case up onto the flaring shoulder. So our handle's all the way down, lift up. Okay, we know that right below the case flaring, we're at 464. We're at 494 and a half. So we need to back this die up just a little. Now, because you're flaring over a short distance, you only want to back that die up a little bit, maybe a quarter of a turn. Again, just finger tighten everything. And to conserve on brass, we'll put that case back into the size die. Pull the handle down to resize that neck. And we'll test it again. Powder bar's all the way over. Less movement. So we've gone from 464 to about 483. We're still flaring just a little more than we need. So we're going to back that die up about 1/8 of a turn is all. And again, just trial and error to get to where you want to be. Resize the case. So we're flaring the case mouth about 17 thousandths. So we're within our 10 to 20 thousand specs. And by doing that, see how the bullet will set partway down inside the case mouth. The next die to install is the bullet seating die. This die will push the bullet into the case to the desired depth. On a Dillon die, if you pull off the top clip, the seating stem, and it's got different profiles on either end of the bullet seating stem. Now, one thing to be aware of is that when you are seating bullets, they're not all going to be exactly the same. So let's grab 3 bullets at random. If you set the nose of the bullet in the seating stem, and with bullet number 1, we're going to measure from the bottom of the stem to the base of the bullet. It comes out at 0.1494 inches. Now when we put the next one in and measure, it's coming up at 1.491 inches. And just for giggles, we'll do one more. This one's just a little different. It's 1.492 inches. Now the reason for that is that when bullets are made, they're made in bulk. And there's always minor variations in where the diameter that the bullet seating stem contacts the bullet. So do not expect all of your overall cartridge lengths to be the same. Typically with most modern manufacturers, you should have a spread of plus or minus 5 to 7 thousandths on overall length. I've measured as much as 25 thousandths in a particular brand. Round nose and spire points are the most common to find the extreme spreads in. In fact, for the guys shooting precision rifle, they have specialized tools to trim the nose of the bullet so that they all measure exactly the same because it makes people feel good. So we'll put this back together. Round nose stem goes in, down, pin, and clip. Now this is in the back station, so it's harder to see. We're going to put our flared case into the bullet seating station, set a bullet on it. With our fingers, we're going to turn the die down until we feel the stem contact the top of the bullet. Now lift up on the handle a little so there's no pressure on the die and turn the die down 1 turn. So we know we're starting to see. You can eyeball it for a little bit. Let's go down a couple more turns. We're going to measure this. It's coming in right now at 1.431 inches. One thing you do need to check for is crack cases. That's the most likely reason for handgun brass to fail, is just from being reloaded, fired, resized, reloaded, fired repeatedly. After 10 to 20 times of doing that, the case is going to get so work hardened that the case neck will eventually crack. And when the case cracks, it doesn't hold the bullet tightly in place. So it's a good idea to sort through your brass, look for anything that's got a crack in it, and pitch it into your recycling bin. So we've got the bullet held in place enough seating wise that we can measure it. And when we measure this, it comes out at 1.430 inches. Now our reloading manual will actually give us at least one, usually 2 different dimensions. The SAMI drawing that headlines most reloading manuals for cartridges is going to show us the maximum cartridge overall length. That means any cartridge loaded longer than that physically will not fit into the magazine for firearms chambered for that cartridge. The other dimension that they give us is, keeping that in mind, the bullet weight, the shape of the nose of the projectile, they will give us a dimension that's a recommended overall length. We're loading a 230 grain round nose bullet in 45 ACP. Recommended overall length is 1.250 inches. That's 25 thousandths shorter than the maximum cartridge length. So now we have a goal to shoot for. So now we'll put that cartridge back in, pull the handle most of the way down, turn that die down, pull it out, measure it. We're at 1.398. So through trial and error, we'll run the die body down until the bullet is deseated to the desired depth. And the idea is you start with the bullet out too far and work it down slowly so that you're not starting by running the bullet too deep, wasting a case in a bullet, and then having to start back it out. Getting close, 1.284, 1.275, so we're at book maximum, 1.260. Now that we're really close, the other thing we want to do is put a fired case into station 1, because that'll give us a little more upward pressure on either the tool head or the frame, so you have the same upward pressure when you're loading as you do when you're seating the bullet. 1.251. For our purposes, that's close enough. So now let's take another piece of brass, flare it. As always, we tighten the die lock ring with the case up in the die to make sure that the die is centered in the threads of the tool head. And when we check that one, we're at 1.254. So we're well within our tolerances. This one's only about 3 thousandths longer than the first one, so we're good to go. The final die that we need to discuss for handgun cartridges is the crimp die. Now, Dillon Precision dies, we've chosen to divide seating and crimping into 2 separate dies because it makes it easier to adjust it separately than trying to adjust bullet seating depth and crimp at the same time. Now, as far as crimp goes, there's 2 styles of crimps. There's a roll crimp and there's a taper crimp. A roll crimp is like it sounds. You're physically curling the side of the case mouth into either a groove or what's called a cantilever, which looks a lot like a dotted line in the side of the bullet. Primarily, it's rimmed cartridges like 38 Special, 357, 41, 44 Magnum, 45 Colt that use a roll crimp. And that's because they can generate enough recoil that as the gun moves rearward under recoil, the bullet wants to go forward and the cylinder acts as a bullet puller. So by crimping that physically in place, it keeps the bullet from sticking out so much that it can keep the cylinder from turning. Semi-automatic cartridges, on the other hand, such as 380, 9mm, 40 Smith & Wesson, 45 ACP, use what's called a taper crimp. Now, a taper crimp is just like resizing the case mouth. And what it's doing is we're getting rid of the flare that we applied earlier to expand the case, and we're squeezing the top of that case snugly against the side of the bullet. However, you don't want to overcrimp. If you overcrimp with a roll crimp die, you'll actually bulge out the case right below the crimp and it may not chamber. Same way with the taper crimp. If you taper crimp a case too much, you in effect resize the bullet inside the case, which is going to reduce accuracy because now the bullet is too small, and the bullet will spin inside the case mouth, so it may not be held tightly when it chambers and can cause a malfunction. Now, there's an easy way to cheat when you adjust your crimp die, whether it's a taper or a roll. So we're going to take our handy dandy sized empty case, put it into the crimp station, pull the handle down so the case is elevated. With your fingers, spin the crimp die down until you feel it stop on the case mouth. That's only your starting point, but it's an easy way to begin because it puts everything really close to where it needs to be. So now, lift up on the handle. We're going to take our loaded cartridge, slide it into the shell plate, run it up, and measure it and see where we're at. Again, our loading manual, the SAMI drawing is going to give you the maximum dimension for the case mouth, meaning Anything larger than that is probably not going to fit in the chamber or into a case gauge. You typically want to crimp 2 to 4 thousandths smaller than that when you're doing a taper crimp to make sure that the bullet is held tightly. And we are right at 472, so see how close that got us? We want to go down maybe another quarter turn. Check it, we're right at 469, which is 4 thousandths smaller than max. And again, when we tighten the lock ring, always have a fired case in the first station and the case up in the die for the lock ring you're tightening. And now, with that cartridge up in the die, we will tighten that lock ring. And now let's check it in our gauge. If you have it, a gauge is just a nice way to check it. It should drop in flush, fall out easily. If you don't have a gauge, take the barrel out of your handgun. Same thing, it should plop right in. Notice that we're just right flush with the hood, the top of the chamber. Falls out when you tip it over. So that way we know the ammunition is going to fit your firearm. And that is how you set up your handgun dies. It's fast, it's easy, and you can do it. Alrighty, I'm going to pause briefly while I change this machine out for 38 special so that I can show you what a roll crimp looks like set up properly. Okay, the alternative to a taper crimp is a roll crimp. Here we have a 38 special case. The bullet is seated to the dotted line, which is called the canlor, so that gives us room to roll that case mouth into that groove. That's its purpose in life, so that under recoil the bullet does not work forward. So let's put that case into the shell plate, pull the handle down, crimp die, screw the die down till it stops on the case mouth. Okay, now that we've got a starting point, we have a cartridge with a bullet seated, put it in, pull the handle down. Now, because you're rolling the case in, you really don't need to use calipers for this. This is more of a visual type of crimp because you're physically curving the case mouth into this groove in the side of the bullet. Alrighty, we've got a good roll crimp, so let's check it on our case gauge. Alternatively, you could use the cylinder on your revolver to check it. Drops in, falls out freely. Our crimp is good to go. Those are the 4 dies that you need to worry about adjusting when you're adjusting handgun dies. It's quick, it's easy, you can do it. It's going to save you money. It's going to allow you to make better ammunition by making your own. Till next time. This is Gary, the Human Manual from Dillon Precision. Thanks for watching.